And those of you who will not be able to attend the lecture for any reason, your internet is not working, you don't have your laptop or whatever it may be, these lectures will also be recorded and available within a few hours after the class, okay, or maybe within a day of the class. Okay, so welcome back to the semester. You've had a nice summer vacation. I've also had a nice summer vacation. As I said, I'm still out of station right now. I'm actually in Canada, and I'll be coming back to India within the next 1 week to 10 days. So until then, classes are going to be online, as I said, right? So we'll continue to do this online, keep recording them and keep uploading them. If necessary, I'll record additional lectures and upload them online so that you all have access to these lectures. So the course, as you all know, is CE314L, Water Resources Engineering. So as is the usual practice, you guys have seen me for the last 1 year. The first lecture is kind of an introduction to the course, how the course will be organized, how we'll go about the timetable, the evaluation, the grades, all of that, right? And then we'll spend a little bit of time on trying to understand what water resources engineering itself is and why we will be studying this, right? So we will try to understand water as a resource, which is of course evident from the name of the course itself. And then we'll see how far we can get in today's lecture. Please keep in mind that if I go past 8:50, any one of you can immediately just unmute yourself and quickly let me know that the time is over, and then I'll quickly wind up the class, right? So that I have to keep track of time here as well, and it becomes a little bit difficult. So because we are doing this online, we'll have some ground rules. Everybody stays on mute unless there is a question. Then you can unmute yourself, and then you can just kind of interrupt me and say I have a question, or I have to say something, or whatever, and then you can go ahead, and we will try to make the class as interactive as possible, so it doesn't feel as if we are physically separated to the extent possible. But of course, it cannot be the same as a physical class. We'll do the best we can. Anyway, I should be back in the next 10 to 15 days max. So we should be able to get back on track soon. All right. So, and then we will quickly get into an introduction to water resources in today's lecture: hydrologic cycle, the different components, precipitation, evaporation, and so on and so forth. Okay. So let's just quickly understand how this course is going to be organized. So we happen to have this wonderful slot at 8 a.m. in the morning, 8 to 8:50, the H slot. I like it because the day gets off to a start. Water resources engineering, it's taken care of. Now it is going to be very difficult to move this slot to another slot, because I know you have courses in the A slot, probably in B as well, and then D, whatever it is. I have another course to teach in the C slot. So moving this course is going to be really hard. So this semester it's going to be 8 o'clock. Let's just assume that that's going to be the way the course is going to run, and let's just see how it goes. Okay, if at all some changes are required, we will try to do the best we can. Okay, let's see. All right. In terms of the textbooks that we'll be using, the first two are going to be the ones that we predominantly use. Applied Hydrology by Chow, very famous, very popular book. You can just search it up online. There's an Indian edition available, which should not be very expensive, maybe 500 rupees, 700, something like that. So if you want that, you should definitely get that book. And then the second one, Engineering Hydrology, Professor Subramania, that one is available as an ebook also, and it is available through our library. So if you go to our library and look up Meg ebooks, you will find Engineering Hydrology listed as one of the books over there, and so you can use the e-resource and legally access this particular book online. Okay, of course, as I said, there will always be illegal versions of some of these books available online. I'm not going to endorse any of that. I mean, library has enough copies available, so it should not be a problem for you to access them. Okay, so that's as far as the textbooks are concerned. In terms of the evaluation, we're going to have one final exam for 50%, quiz 1 and quiz 2 for 15% each, so that's 30%. And then throughout the semester, we will have a series of mini projects, probably four, maybe five. Four to five is the general number that I stick with every semester. So we'll have about 4 projects for 20% of the grade. So this is how the course is going to be graded throughout the semester. If there are any questions, you can feel free to unmute yourself and just speak up, or you can bring up your concerns to the class representative, who can bring it up during the class committee meeting, which will happen in the next 1 week or 10 days. Okay, so if there are any questions right now, we can address them right away. Any questions? Okay, I'll assume that no questions. And then the usual distribution for the grades, 90 to 100, 80 to 89, and so on. And again, from experience that this is something we've been following over the last couple of semesters also. We'll continue to use this semester as well. And as I said, I've been doing this for the last 8-9 years. And this grading pattern somehow seems to work pretty well in most of the cases. I've not had any major complaints so far about this. Okay. All right. Now we will try to understand. Let's get into the topic right away. So the course title itself says Water Resources Engineering. Now immediately the question, everybody knows what water is. Engineering, I guess we have some idea of what engineering is, but then there's this word in between, water resources engineering. So the question that immediately becomes obvious is, why water resources? What is so special about this word? Okay, I'm trying to use my little marker pen that I have. Hopefully it's I'm able to do a good job. Let's see. Okay, so anybody has thoughts on why we have the word resource here and why it's relevant to us in this context? Anybody can unmute and probably speak up. Okay, I know it's the first day. It's 8 a.m. on a Monday morning. I know it's hard, but it'll be good if we have. It's a basic general kind of question. It'll be good to have some kind of interaction so that we get used to coming back to classes and the usual pattern of how our classes go. Right? It's always interactive. So let's have a few words at least. Anybody would like to say why? What is the relevance of the word resource in the title of the course? Nothing? Okay, so would anybody like to tell the class any other resource that you're aware of? Forget about water for now. Are there any other resources that we know of that will help us to understand why we are trying to understand water as a resource? Okay, silence work, guys. You guys, somebody has to speak up. Any one of you, or shall I call out a name? Okay, let's do that. I think Chaitanya was in the class. Chaitanya?
Sir,
Yes. What do you think is the significance of the word resource? Or you can say anything you understand by the word resource. What is? Give us an example of any other thing that's a resource. Okay. Okay, let's think of this example. You have all heard of the word human resources? Everybody knows human resources. HR. Why is human resource? Why do we call human beings a resource? Okay, is time a resource? Time? Yes, no? Anybody? Arya?
Sir,
Yeah. Is time a resource?
no, sir.
Time is not a resource. Okay. Is water a resource?
Because we will use water, so the things which we need to survive, we need to have to survive. They are called resources.
Okay. Okay. But then why do we say human resources? Human resource. I mean, we of course need other human beings to survive. That is true. But that's not the context in which we say human resources, right? Human resource is part of like a company has a human resource department, right? Okay. Anybody else would like to shed any light on, is time a resource? Suppose I give you an assignment. I'm not going to give you an assignment, but suppose I give you an assignment today and tell you that it's due in 1 week. That means you have 1 week of time available to do that job, whatever I give you, right? You don't have unlimited amount of time. You only have limited amount of time, and within that time you have to finish a certain amount of tasks, right? Whatever it is, I may give you 10 problems, 20 problems, I might give a paper to read, whatever it may be, right? A certain task is assigned and there is a certain time available to do that task. So therefore time is also a resource that you use to accomplish that task, right? Anybody else? Somebody's unmuted. Okay. So time is also a resource if you think about it. Let's say petroleum, is that a resource? It is a resource. Oil and natural gas, these are resources because okay, the idea behind the word resource is something that is uh, either limited in quantity or limited in terms of the time at which it is available, right? So anything that is limited in quantity or maybe quality also, you can think of that as a resource. Even sunlight is a resource, right? Because you don't get it 24 hours a day. If you want to grow a plant, you need sunlight. And if you don't have if you have sunlight for some hours in a day, then you have that resource available for only that duration. So if you want to grow a crop, it can only happen if sunlight is available. So human resources, time is a resource. Uh, Sunlight is a resource. Water is also a resource similarly, right? Because if I want to, if I take the same example of a crop, if I want to grow or wheat or sugarcane or groundnut or any crop, right? To grow that, I need a certain amount of water and I need that water to be of a certain quality. I can't take any water of any unknown quality and use that to grow my crops and so on and so forth, right? So any resource is anything that is useful for us to do something productive, whether it is time, money. Money is also a resource, right? Or water or petroleum or human beings or animals. If you are using animal power to, if you, for example, 200 years back, there were no cars, there were only horses and bullocks. So you use that to move from one place to another, right? So they are also a resource. Metals, iron ore is a resource, copper, aluminium, all of these are resources because they are not available in any quantity that you want and of any quality that you want. They are limited in quantity, they are limited in quality, they also spatially limited. Spatially, I can even say temporally, right? I need water every single day of the year, but it doesn't rain every single day, correct? To survive, I need about 100 liters of water every single day as a human being in a civilized uh, world. Every human being requires about 100 to 130 liters of water every single day to survive. But we don't get 100 to 135 liters of water as rain every single day. But we are still able to supply the water throughout the year, although we don't get rain throughout the year, right? And whether you are in Rajasthan or in Assam or in Andhra Pradesh or in Jammu Kashmir or wherever in the country you are, you still need water. But the water availability is not uniform, right? Rajasthan has much less water than Assam. Karnataka or Andhra Pradesh or Tamil Nadu has less water than UP or Punjab, for example, right? So not only is the water availability varying in space, it is also varying in time, because the monsoon only happens from, let's say, the 15th of June to October, maybe, depending on which part of the country you are in. So right now it's what, the early August in our on our campus. Now I have not been on campus for the last 2 months almost. So if you guys have come to campus, if you walk over to the ponds, you will see what the water level in the pond is. When you left in the month of May after your exams, the water level in the pond would have been at a certain place, right? Today, when you get a chance today in the evening or sometime later, make it a point to go and visit the pond and see what the water level is. And think what has happened between May when you left the campus, on that day when you left, where was the water level? You might remember, or you might have taken a picture or a photo or something like that. Just to look at that and look at it again today and see what the difference is. What has happened between May and August 4th? There, the monsoon has arrived in the southern part of India. And so therefore the water has started to fill into the pond. Now I have not been on campus. I don't know what the water level is, but I'm assuming that it is very likely it is higher than what it was in the month of May. Okay. So that's why water is a resource, and which is why we need to understand it, because our job as civil engineers is to ensure the supply of water, whether it is for human consumption, you're drinking water, or for bathing and washing, cleaning your house, cooking, all those things. Or if you are a farmer and you require water for irrigating your crops, the civil engineer is responsible for supplying that water to the farmer through construction of dams, through construction of canals. Now, in the previous 2 semesters, you have understood about the physics of water, right? We're going to talk about that. In the last 2 semesters, we have understood the physics governing water. So we understand how water behaves when it is at rest, when it is in motion, when it is flowing through a pipe, when it is flowing in a channel. All of these things we have understood. Now we are going to try to understand how to deliver that water, or how much water is required by the end user, right? So because water is going to be used for multiple purposes. It could be used for irrigation, it could be used for domestic purposes, which means for household activities, drinking, bathing, washing, cleaning, cooking, all of that. Or it could be an industry which uses water, right? So that's why it's important for us to understand how water is distributed in the natural environment through different processes. We'll try to understand that in this course, and then that will help us to move forward with how to manage it, right? Because you might have heard this phrase sometime in the past, that it is impossible to manage something that you don't measure. Have you heard that? If I tell you, I want to manage your financial affairs, right? So let's say you have X amount of money. I want to know how much money you have, how many years you can live with that kind of a lifestyle, and so on. So then I need to know how much money is your income. I need to know what are your expenses, right? So I will start measuring all those things. Where are you getting money from? You're getting a salary, you have some fixed deposit which is giving you some interest, or you have some savings, all of things are earning money. So those are the ways in which money is coming into your bank account. And then I'll try to find out all the different expenses that you have. You know, you have a credit card, or you have an EMI for a house, or you have a car, or you're paying rent, or you have this or that. All of those expenses, those are, uh, I need to measure how much your expenses are. I need to measure how much is incoming, and then I can plan out how you can save more money or how you can manage your expenses, right? So unless you have some numbers, it becomes difficult to manage. It's the same with water also. If I want to manage the water, I need to know how much water is being used for different purposes, how much water is I'm getting through natural processes like rainfall, snow melting, and so on and so forth. So unless I have information about all of these processes, it becomes very difficult to manage. Okay, somebody unmuted. A question? Okay, so feel free to interrupt me if you have any questions or whatever. Okay, don't worry about it. Okay, so as I said, it varies in quantity and quality, the water that's available to us, and it is spatially and temporally distributed, right? You don't get the same amount of water in Andhra Pradesh as you get in Rajasthan, as you get in Uttar Pradesh, or you get in Assam, or any other part of the country, or any other part of the world. And it is temporally distributed. Between the month of January and May, most parts of India get very little rainfall. And between June and October, maybe November, maybe a little part of December, depending on which part of the country you're in, you may get rainfall, right? So there is both a spatial distribution of water and a temporal distribution of water. And these two processes combined together makes it difficult for us to, uh, you know, manage it efficiently. So if every day it rains 10 minutes, all you have to do is take a bucket to your terrace, fill the bucket, bring it down, and then you're done. Depending on how many people are there in the house. If you have people in the house, then you take 10 buckets and fill them up. You'll get some, I don't know, 10 buckets. Well, not too much. You get only 200 liters of water. Each bucket is around 20 liters. Okay. Anyway, so if depending on the number of people, you can take a bigger bucket, just fill it up. If every day it rains, but there is no place in the world where it rains every day, right? So therefore, that's not possible. And then, depending on if your house is in Rajasthan or Assam, even if it rains, you won't get the same amount of rain everywhere, right? Anyway, so that is the idea of why and how water is a resource which requires civil engineers to understand this resource, try to, you know, manage the distribution of water for these different purposes, whether it's irrigation or for domestic purposes or industry. So now the different processes that keep water in circulation, all of you know this, but I'm just going to quickly go over some of these. You might these Some of these words you might not be familiar with. If you're not, we'll try to understand them in a little bit more detail as the course goes on. But a lot of them are very, very obvious. Rainfall, everybody knows what that is. Evaporation, everybody knows what that is. Infiltration, kind of sounds like you know it, but if you don't understand it, well, it is water when it falls on the land surface. It can go into the ground. That process, simply speaking, you can call it infiltration. Now, the root word there is filtration, right? So filter means when water passes, let's say you must have done these chemistry experiments in lab where you keep a paper filter and then you pour some water, whatever it is, right? If there are any suspended solids in the water, they get trapped. That's what we call filtration, right? Now, this infiltration, it's called infiltration because soil is a porous membrane or a porous material, and when water falls on it, the water passes through the different soil particles and goes through the pores. So that's why we refer to that process as infiltration. Okay, so that's a very classic process in the hydrologic cycle. And then there is stream flow. Everybody understands what that is, right? The rivers are flowing, so the flow of water in the rivers or streams, we generally refer to it as the term stream flow. And then now there's the word GW refers to groundwater. Okay, groundwater flow. Now, depending on whether you are aware of this or not, this might be new information for you, right? So groundwater also flows. It is not a stationary body of water. Okay, groundwater is any water that is present under the land surface, right? Any water that's present above the land surface, like a river or a lake or a stream, we refer to that as surface water. And any water that is present below the land surface, either as soil moisture or in the aquifers. Again, another word that you might not have heard before. Aquifer is basically a geological unit that is present under the ground, under the land surface, right? The water that's present under the land surface is not stationary. That water also moves. So that we refer to as groundwater flow, right? So these are some of the processes that keep water in circulation in the around the planet. Okay, so you might have heard of the phrase the water cycle or the hydrologic cycle. So we will discuss that in today's lecture. Okay, now you must have seen this, you must have heard this. People show you a glass of water and then say, is this glass half full or half empty? Okay, everybody's heard this. Nobody knows what the answer to this question is. Does anybody have an answer to this question? Anybody would like to answer this question? Is this glass half full or half empty? Or is it both? Nobody wants to answer? Let's see. Let me see who I can call. Uh, Ayush,
Yes, sir.
what do you think? Is the glass half full or
Uh,
half empty?
I'd say the glass is half full.
It's half full. Okay.
Yes, sir.
Thank you. Thank you, Ayush.
Yeah.
Aditya, what do you say? Okay, there's feedback over there. Okay, we'll go to Harsh. Okay, he left the meeting just as I said his name. Okay, Harshit, half full or half empty? Okay, Manohari, half full or half empty? There's no wrong answer. Go ahead. Srividya,
Sir,
go ahead.
sir, half full, sir.
Half full. Okay, you're all optimistic people. Very good. Puneet,
Sir, I would say it is not both of them
okay.
because it is not a closed container because it's open container. It doesn't have a boundary.
Okay, what is the, it's not a gas, right? Water is, there's a finite volume for any liquid. Gas will occupy the volume of the container. But in the case of a fluid, there's a free surface which determines that that's the boundary of the fluid. If the
Okay, then it
if I
then
close
it
this glass,
doesn't.
if I put a lid of the glass, then
It will be full. I think
half full or full,
half full. Yes, sir.
half full. Okay. Anybody else? Arpita,
Yes, maybe it's awful.
half full. Okay. Okay. Anybody thinks it's half empty? Everybody is an optimist in this class, huh? Very good.
In the perspective of
In the prospect of,
air,
huh?
in the perspective of air, we can say it is half empty. In the perspective of water, we can say half full.
Okay. Okay. I have three answers to this question. Actually, I have two answers, and then I have a third question, third comment or question, whatever you want to call it. Okay. Suppose we are filling water into this glass. Okay. Then I will say this glass is half full because I have started filling it and I've stopped filling. At this point, I have filled it up to half. Suppose I'm drinking water from this glass, then the glass is half empty. And this is just my answer. I'm not saying it's the correct answer because I've not completely emptied the glass. So I've finished drinking half the glass. So it is half empty if I'm drinking from it. If I'm filling water into it, then it is half full because I have not completely filled it. Okay, that's one answer. Now, let us imagine this glass. Let us imagine this glass 48 hours from now. Today is Monday morning. For you, for me right now, it's Sunday evening, but that's okay. Let us imagine that day after tomorrow, when we have the class again, when we meet again on Wednesday morning at 8 o'clock, the same glass. I bring this glass to you. What do you think will happen then? Will your answer be the same? Or will your answer be different? It's a trick question. It's a little bit of a trick question. Depends on what you do with this glass. If I leave this glass in the classroom, okay, let us imagine we are sitting in the classroom. I leave this glass here. Nobody touches it for 2 days. We come back on Wednesday morning at 8 o'clock and we look at this glass. What do you think would have happened to this water in the glass? You think anything would have changed or nothing? There's not going to be any change between then and between today and 2 days from now. Will the water level be the same or will it be different 48 hours from now? Has nobody tried this?
It will be different.
Okay, can you tell us what way it will be different, Aditya?
Most probably the glass will be fully empty because the water will be evaporated.
What, the glass will be fully empty because the water would have completely evaporated. Depends on where you are. If you are in Rajasthan, maybe it will evaporate in 5 hours. If you are in some other part of the country, it may evaporate in 12 hours or 24 hours or 48 hours or whatever it may be, right? So it really depends on at what stage you are looking at this glass. At this point, the water is at a certain level, but if you look at it, the same glass without interfering with it, then its state is going to change. This state is a snapshot in time. If the same glass is kept on the terrace of the building that we are in, okay, and you come back 48 hours later, it depends on if there was any rain in the last 2 days or not. So which is exactly why I'm saying that the reason, actually, I mean, this is something that that happened about 2 years ago. 2 years ago, you might know that the syllabus or the curriculum went through a revision. You guys are the first batch to go through the revised curriculum. Okay, when we were shifting the courses and doing all of that, this water resources engineering course, there was a debate whether to move it to January or to keep it in this August semester. Okay, and I'm happy to report that I insisted that it should be kept in this August semester. And the reason I said that was between August and November in Tirupati, we get a lot of rain, we get a lot of sunshine, we have the ponds on campus. So you can actually physically observe every single thing that we teach in class. You can observe just by being on campus. We'll talk about rainfall. You will observe rainfall happening. We will talk about soil moisture. You will observe that. We will talk about stream flow. You will see streams flowing. The little streams that we have on campus, they will be flowing. We'll talk about evaporation. You can't see evaporation, but you can see the effect of evaporation. You've all seen the effect of evaporation, and so on and so forth. So almost every process that we talk about during the semester is going to be observable on campus, right? So if you were to take this glass and keep it in your room or keep it on the terrace and observe this glass over the course of the semester, you will observe the water level going up and down in this glass. There's a reason I put this. I mean, of course, it's a funny kind of half full, half empty. Everybody looks at this. Nobody knows what the answer is. But this glass, you can think of it as a kind of a thought experiment that you can do. If I kept this glass on the terrace and observe the water level every day, just by observing that, I would know whether yesterday, suppose I don't know anything that happened between 8 o'clock today and 8 o'clock tomorrow morning. I just go into my room and then never get out of my room. But at 8 o'clock, somehow I go to the terrace and check the water level in the glass. Just by doing that, I know whether it rained yesterday or whether it was a very sunny, hot day yesterday. Right? So this glass of water, although it looks very, like a simple little thing, it can actually convey a lot of information. And if you actually do this experiment, you can do this experiment. It's not very difficult to do. Of course, if you keep it in the terrace, somebody else might, something might knock it away or whatever it is. But you can keep it in your room and observe what happens. Take a glass, fill it with water, mark it today's with date or whatever. You can even do a time lapse video or whatever it is. Keep it in the same place. Take a video every single day, and then that would be an interesting thing to do. Okay. Of course, you can do that with a real life glass. Instead of doing it in your room, you can go to our campus ponds and take a picture every day from the same spot and watch how the water level in the pond changes as a function of time. That would be an interesting time lapse video. Okay. Anyway, just something to think about. Okay. So I'll just leave that as a kind of aside for you to think about. Okay. So now let us look at the global water resources. Because we're talking about water as a resource, this is something that you need to understand. So if you look at all the water that's available on the planet, okay, now this is something that they say the Earth is sometimes also referred to as the blue planet, right? Because it's 97% of the, not 97%, some large percentage of the surface of the Earth is covered with water, the oceans, okay, and the land is only covering, I think, less than half. Less than 50% of the surface of the Earth is covered with land. The rest of it is covered with water, which is why the Earth looks blue, right? When you go to space and look at the Earth, you see that, it's blue in color, right? Now, interestingly, if you look at all the water that's available on the planet, 97% of it is salt water. It's in the oceans, okay? And only 3% of the water that's available on the planet is fresh water, right? So now when I talk about water resources at the point of view of consumption, and when I say consumption, I mean for domestic or for irrigation or for industry and so on. For these types of consumption, I need fresh water. I cannot use salt water directly. Otherwise, I have to convert that salt water through an expensive process, desalination and so on, to make it fresh so that I can use it for various purposes, right? So now this 3% fresh water that we have on the planet, that again, I'm going to show you another subdivision of that, right? Out of the 3% fresh water that we have on the planet, around 69% is locked in the ice caps and the glaciers, which means the North Pole and the South Pole, and then all the big mountains, Himalayas and the Alps and the Rockies and so on and so forth. The glaciers on these mountains and the North and South Pole together account for around 69% of the fresh water available on the planet. Okay. And then around 30% of the fresh water is groundwater. Now, this is something that blows the minds of a lot of people. Okay. And then 0.3% of 3% is the surface water that you see physically, that you see. So all this 0.3% is basically all the big lakes, the rivers, the wetlands, everything that you see on the surface of the earth, right? That is 0.3% of 3% of the total water available on the planet, right? Which means all these big rivers that we have around the world. Did we do this exercise last semester in the hydraulics course? Where we went around the class, everybody had to name a river. Did we do this before? If you've done it already, we won't do it again. Revant, did we do this last year in the hydraulics course?
Sir.
Did we? I usually do this kind of a game where I ask everyone to name one river.
Yeah.
Did we do it last semester?
Just to name the rivers here.
Yeah, we did, right? Okay, fine. So all the big rivers in the world, right? Whether it is the Ganga, Brahmaputra, Narmada, Kaveri, Godavari, Krishna, Yamuna, Indus. Now everybody knows about the Indus because of what happened in the last 2-3 months, right? Indus Water Treaty and so on, or the the Nile, or the Thames, or the Mississippi, or the Colorado, or any river in the world, right? You think that's a lot of water, right? That's less than 0.5% of the total fresh water available on the planet, right? If you look at all the fresh water available on the planet, less than 0.5% of the fresh water is all these big rivers. When you think of water, you think of rivers, right? That's the first thing you think of, but it's a very tiny, insignificant portion of all the water on the planet. But of course, it is only insignificant in terms of the percentage. But if you look at all the civilizations, the Indus Valley civilization, the Egyptian civilization, or the Mesopotamian civilization, or the Chinese civilization, all of these have happened along the banks of rivers. So rivers are very important because that's where civilization has started and prospered and so on and so forth, and we have come all this way. Okay, now if you look at this distribution of groundwater versus surface water is only 0.3% of the fresh water. Groundwater is 100 times more than surface water, right? 30% is 100 times 0.3, right? Approximately. So, but in this course, right, because of the way we historically we have understood water resources, we will spend around 75% or 80% of the semester understanding surface water, and the remaining 20% or 25% of the semester we will talk about groundwater. Okay, that's just the way the science of hydrology has evolved over the years. Okay, it's disproportionately focused on surface water, and we pay very little attention to groundwater, which is one of the problems with the way we teach hydrology. But that's just the way it is. Okay, because surface water is easily visible, and you can do you can construct dams, you can construct canals, and so many major infrastructures can be constructed, and therefore we need to understand it, or we have spent a lot of effort understanding it. Groundwater, on the other hand, you just drill a well, you've got some groundwater, right? So therefore very less time is spent on understanding groundwater, also because groundwater is not visible, right? It's invisible, so we don't pay a lot of attention to it, right? Anyway, so that's as far as the global water resource this thing is concerned. Now there's another minor point here. So even out of that 0.3%, again we're just breaking it down further and further, only 2% of that 0.3% is all the lakes have way more water than the rivers do. But somehow we are conditioned towards thinking about, whenever I say water, you immediately think of rivers. But if you look at them in the global picture, rivers are a very, very tiny fraction of the total water that's available on them. Okay, so this is just something to keep in mind. Okay, it doesn't mean that we will spend the time that we spend this course will not be in this proportion. Okay, we will spend a lot of time on understanding stream flow, because most of our energy is going to be focused on understanding how much water or what quantity of water flows in the rivers and so on. Okay, so that's how the course is structured, or the science of hydrology has been historically been developing over a period of time. Okay, all right. So I have one more slide. Okay, well, this is now look at this rainfall map. This is for the year 2022-23. I've not got an updated version of this because I'm outside the country. I'm not able to access this website, so I was not able to get a more updated version of last year's rainfall. But anyway, so June 2022 to May 2023, if you look at the map of India, you are able to see how rainfall is distributed across the country. Okay, so you can notice that there's portions of the country where it's red in color. It gets less than 600 millimeters of rainfall. Okay, so which is maybe majority of Rajasthan, little bit of Leh, Ladakh. That portion also gets very less rainfall, and that 600 to 1000 is kind of this slight light orangish color, which is again covering a significant part of India. And then you have this blue portion, which is all along the western coast of India, where you get more than 2400 or more than 3400 millimeters of rainfall. Extremely high rainfall amounts. And again, you see that again in the northeastern part of India, Meghalaya and Assam and Arunachal Pradesh and so on. They get quite a lot of rainfall, right? So the northeastern part of the country and then the southeastern coast of India are the portions of the country which are the highest rainfalls. Okay, and where we are is over here, Tirupati, right here, we are getting around 1000 to 1400 millimeters of rainfall over a year. Now, you may notice that I have not shown January 2022 to December 2022. I have shown June 2022 to May 2023. There's a reason why I've done this. Okay, this time period that I've chosen is referred to as the water year. Right? The water starts from June 1st of every year and ends on May 31st of the next year. Right? The calendar year, we know it starts on January 1st and ends on December 31st. The academic year, which is what you are going through, it starts in August and ends in kind of May. Right? And then you have a financial year which starts on April 1st and ends on May 31st, something like that. Right? So there are different ways in which you can we understand the same 12-month period. You divide them in different ways to help us understand how this resource is distributed. So in the case of water, why do you think we have this distribution from June to May? Why not January to December? Why not February to January? Or why not any other way of cutting the year? Why from June to May? Any thoughts on that?
Because southwest monsoon starts on June.
Correct. The southwest monsoon.
And like after May, like there'll be summer rains included. The May.
Yeah. So you're almost there, Puneet. So the answer is that by end of May or early June, that's when the southwest monsoon. So there are two monsoons in India. For those of you who are not aware, there is one monsoon which comes from this direction. Right? It comes from this direction. This is called the southwest monsoon. And then there is the other monsoon, which is called the northeast monsoon. So I'll just write it in short, NE, northeast monsoon. Okay, so India has the major monsoons. One starts in the month of June, southwest, June 1st to around October, September end is the southwest monsoon. Northeast monsoon is from around October 1st or October 10th to around December 15th, right? So that's the duration of the two monsoons. These are the two major systems that deliver water or deliver rainfall to the country. And the southwest monsoon pretty covers the whole of India. Northeast monsoon is predominantly for Tamil Nadu, Andhra Pradesh, Orissa, maybe even Telangana, and West Bengal. That is the region that is covered in the northeast monsoon from October 1st to December 10th or December 15th. That is the duration. So because of the beginning of this June 1st is when typically the southwest monsoon starts. So therefore, we have the distribution of this water year from June 1st to May 31st of the next year. So that's the logic behind having this year from this time period. Okay, I have another similar map for depth to groundwater level. Again, some of this data might not be very accurate. For example, you see that the whole of Uttar Pradesh has got just one color, 10 to 20 meters. That's not because the water level across Uttar Pradesh is the same number. It's because they only have one data point and they've just extrapolated that for the whole state, right? Or they have just averaged all the data points and given one answer. This is a kind of number in, this is the state of Meghalaya, I think. Meghalaya over here also has only one color. It's impossible. Everywhere else you see different colors corresponding to different depth of water table. But in states, for some reason, they only reported one number. So therefore, you see one color for the whole state. It's not possible. Okay. Anyway, so this is again telling you how the water level in different parts of the country is behaving. In some places, the water level is between 0 to 2 meters from the ground level. In some places, it's 2 to 5 meters below ground level, and so on. So these different colors are denoting how the water level changes over a period of time. Okay, so I think we are out of time. So we will continue again on Wednesday, 8 o'clock. See you guys on Wednesday at that time. And if you have any questions, please send me an email. You can also post in the Google Classroom. I will share the recording of this lecture on Google Classroom within the next 24 hours or so. Okay. So thank you very much. Take care and see you guys on Wednesday. All right. Bye-bye.